Have you ever wondered about how your brain and how a computer process information? It turns out they're pretty similar, especially in categorizing objects and making predictions. This falls under a branch of computer science called machine learning. Pretend you've never seen a dog or cat before. How do you tell the difference? After being told that a dog is a dog and a cat is a cat, and seeing many images of the two, your brain begins to understand the difference. A computer can do the same. By training and testing an algorithm with images of dogs and cats, that algorithm can predict which is which, just like your brain would. One common way to supervise the program to make a prediction is with a neural network. So what's a neural network? It is the algorithm we train to recognize differences and similarities. Neural networks consist of an input layer, hidden layers, and a final output layer. We can divide the whole process into 4 general steps. Number 1, weight and bias factors. Picture a virtual image of a cat. The image you're seeing is made up of small single-color pixels. A neural network can take in these pixels and assign each one to a separate neuron. It then correlates each pixel with a set of values, known as weight and bias factors. This initial conversion of a visual pixel into a series of numbers is known as the input layer. Number 2, hidden layers. The numbers are then sent to the hidden layers. These neurons in these new layers take in a group of weight and bias factors from before and convert them into a probability, from 0 to 1 via an activation function. The output value of this layer is the probability that the input pixels are a part of the cat. Output layer. Finally, the probability outputs in the last hidden layer are analyzed, categorizing the image as a cat as opposed to a dog. Number 4, error calculation. The problem is, at first, a neural network will have no idea which correct weight and bias factors to assign to each pixel. A neural network has to be trained in order to recognize a dog from a cat. By using a system called backpropagation, the network refines its work. The network is initially fed images of dogs and cats and told which animal each picture is. Based on the neural network's prediction, an error is calculated using a special function in order to determine whether or not the final output is accurate. If the error is high, the weights and biases are altered in order to minimize the error. By iterating this over and over, the network becomes able to predict what is a dog and what is a cat. It will be able to receive a new image of a dog or cat that is outside its training set, just like how your brain would do if it received a new image of a pet. If we see this image, we know cat. Our brains and computers really do think in similar ways.